All right, 7.6, solving absolute value inequalities. So an absolute value inequality is exactly what it sounds like. It's a inequality with an absolute value in it. Now we dealt with these in chapter 1, and we know that there's some special rules that we have to use whenever we graph these, whenever we solve them. Starting off though, I want to just graph these two examples. We have the absolute value of x is less than 2, and the absolute value of x is greater than 2. So here on the left, actually I'm going to draw a little line here to separate them. Starting here, absolute value of x is less than 2. Well, I'm going to put a number line. I've got 0, I'll have 2, and I'll have negative 2. Absolute value of x is less than 2. So 0 would be included, right? Would 2 be included? 2 would not be included, right? But it would be right up next to it. If we had 1.99, that's less than 2. If we had absolute value of negative 1.99, that's less than 2 also. So I'm going to put open circles on the 2's. And then we said that we know that 0 is included, so 0 has to be shaded. I'll shade between them. Now I want to check something outside of it, like 3, and we'll check negative 3 also. If I plug that in, absolute value of negative 3, that's a 1. Negative 3 is less than 2. Well, no, that's not true. Similarly, the absolute value of 3 is not less than 2 either. Right? So it's that middle piece there. Now, if we have absolute value of x is greater than 2, we'll draw my number line again. Again, we're going to have open circles on the 2's. And then absolute value of x is greater than 2. The number 3 would fall into that. So I'm going to shade this one to the right. The number negative 3 would also fall into that. So I'm going to shade the other one to the left. Now what we should notice or recognize is that this is similar to a and from yesterday. This is an or from yesterday, or from the last section. So we're going to have some special rules about the direction of the inequality with the absolute value bars. So you don't have to copy down this word for word, but I think it is something that you'll probably want on a note card or some notes that you can keep out while you do your homework. It says, let C be a positive real number. Okay, so to solve the absolute value of ax plus b, where ax would be something like, I don't know, 3x plus 6. That's what that's saying. Some kind of number like that. So if we have absolute values and it's less than c, we solve the compound inequality with the absolute value bars removed, with it greater than negative c, and absolute value bar removes less than positive c. Okay, the thing there is that we have this symbol and the word and. Then we have this symbol where the absolute value bars are larger than c. We're going to end up using or, right? And that goes along with what we had up here. Absolute value, or the inequality is pointing towards the absolute value bar. That's what we have right there. Inequality is pointing towards C. That's what we have right there. So let's start off with this one here. This one is going to be, it's less than, so it's going to be using and, right? So we can do this a few different ways. Let me show you the first way that would be following the directions that they have here. So this would be saying we'd have x plus 3 is greater than or equal to negative 2. And then also x plus 3 is less than or equal to 2. And what I'm doing there is I'm plugging into this formula right there. And I can solve that, or here, let me put the word and in there. I can solve that just like normal, just like our normal compound inequality, and we can graph it. Another way to look at this, okay, this only works for the ands. This only works for whenever the absolute value bars are less than the number. Okay, it only works for the things that I have like shaded yellow. We could separate this and we could say, well, negative 2 is less than or equal to x plus 3 is less than or equal to 2. You could write it as a single, right? Looking here, this tells me the absolute value of x plus 3 is less than or equal to 2. That means that it's wedged between positive 2 and negative 2 because of the way that the absolute value bars work, okay? I will normally do it this way because I think that way makes more sense and it works a little bit faster. You can also do it this way. So I'm going to look at this one and I'm going to solve. Whenever I subtract 3 from both sides, I would end up with negative 5 is less than or equal to x is less than or equal to negative 1. So whenever I graph this, let me see if I can get everything in there. I'm going to have negative 5, I'll have negative 1, maybe we'll put 0, and it'd be negative 6. I'm going to have closed circles on negative 5 and negative 1, and it says x is wedged between them, so there we are. Now, on these, I recognize that these can be a little bit confusing sometimes. To check yourself ever, just pick a number. Maybe this is, I don't know, negative 2. Or we'll do negative 3 because there's too many 2's in this. Negative 3. And you can plug that in. We'd have absolute value of negative 3 plus 3, absolute value less than or equal to 2. Well, this is 0 less than or equal to 2. So yeah, that works. You can always check yourself if you're confused. All right, next up, a definition. The absolute deviation, right? Absolute deviation. The absolute value of the difference of x and a given value. Okay, and then in normal terms, absolute deviation is how far away two numbers are. Okay, they're how far away two numbers are. If we're talking about one number being x and one number being 5, you'd subtract them and find the absolute value. Okay, this would be the same thing as the absolute value of 5 minus x. Okay, what this is doing here with the absolute value bars is if you're trying to find how far away, we'll say the number like 10 and the number 5 are, well, we'll not do 5, we'll do 4. If you're trying to find how far apart those two numbers are, we know that it's 6 because 10 minus 4 is 6. But also, 4 minus 10 with absolute value bars is 6 also. So this is saying that if you have the absolute value bars and the two numbers subtracted, you will always find the difference or how far apart they are. All right, deviation means how far apart. All right, let's look at number 2. This is our last example. We're supposed to graph, and there's a lot of extra stuff in here. What we're going to do is we're going to deal with the absolute value bars very last. Okay, deal with them last. I'll start off by subtracting 5.5 from both sides. So this will give me negative 3, absolute value of 2 minus 4x, absolute value is less than 5, 6, 7, 8, 9, negative 9.6. Now, we still don't want to deal with the absolute value bars yet. We're going to divide both sides by negative 3. That'll leave us with absolute value of 2 minus 4x on the left And then we divided by a negative, so we have to swap the sign, or swap the direction of the sign. And then whenever we divide this, I've got negative 9.6 divided by negative 3, and I get positive 3.2. Now, I'm trying to remember in my head without looking up at the what we wrote earlier. Is this going to be an and or an or inequality? Well, it says that this is larger than this. So that would include like the number 5. It would also include like the number negative 5, right? Because we take the absolute value of it. So that means that it's going to be on either side of it, right? It's going to be an or. Over here, let me put this out. We've got 2 minus 4x is greater than 3.2, and 2 minus 4x is greater than negative 3.2. Excuse me, is less than. Solving this, I subtract 2 from both sides. So I'll have negative 4x is greater than, what is that, 1.2. On the right side here, I'll have negative 4x is less than negative 5.2. And then dividing by negative 4, and I'm going to get myself a decimal. I'm going to have x is greater than 0.3, negative 0.3. And on the right side, 5.2 divided by 4 is 1.3. So x is going to be greater than 1.3. Right, I swapped the sign of my, I need to do that on the left. You have to swap the sign of your inequality because you divided by a negative. Right, and this is an or. So I have a number line, I have negative 0.3, I have positive 1.3, I have open circles on both of them. The left one tells me x is smaller, so I'm going to shade to the left. The right one tells me x is bigger, so I'm going to shade to the right. That one was kind of a long problem, but hopefully we get the gist. All right, that is all. Let me know if you need help on your homework.